In this video, we're going to take a look at treating dependent events as independent. So here, when we have calculations that are cumbersome and we have the sample size is no more than 5% of the size of the population, then we can treat selections as being independent even if they are not. So you might say, well, why does that matter? Why does that matter? Well, let's look at an example and we'll see if we can see why that might be nice for us. So here's our example. A sample of 700 American internet users ages 18 to 24 found that 546 were Snapchat users. So our first question is this. What is the probability that one person randomly selected from this sample of 700 is not a Snapchat user? Right, so the probability that they do use would be 546 out of 700. That's like 0.78. The probability then that they do not use would be 1 minus 0.78. So if we just select one person, the probability from this sample, the probability that they do not use Snapchat is 22%. That was not so bad. We didn't use anything about independent or dependent events there. Let's look at the second question. The second question says, what happens if we pick 3 people from the sample? What is the probability that none of those 3 use Snapchat? So we're selecting 3 out of 700. And we can observe that this is less than 5%. Right, 3 out of 700 is less than 5%. It's a little bit less than half of a percent, somewhere around there. And so we can treat these events as being independent when in fact they are dependent. And so we can say the probability that the first does not use and the second doesn't use and the third does not use is equal to the probability that each one of them individually does not use. So first one has a probability that they don't use of 0.22. Second one, we're going to use 0.22. And the third one, we use 0.22. Or 0.22 cubed. All right, so that 0.22, that came from our answer from above. The probability that none of these 3 use Snapchat is 0.0106, or 1.06%. So that gives us an approximation. That approximation is an okay approximation to use. If you didn't want to do an approximation, then what we would have done instead, we would have said, well, we have 546 that use Snapchat. That means that 154 do not use Snapchat. So we have 154 out of 700. That's the probability the first person doesn't use Snapchat. For the second person, we want to know what's the probability the second does not use Snapchat, given the first did not. So that would be 153 out of 699, because there's one less Snapchat user and one fewer user overall that we could choose. And then we would have 152 out of 168. Not 168. 698. So this is the actual calculation. This is the true value. But when we have cumbersome calculations, that value works. It's a decent approximation. Now, it might depend on what setting you're in, if a close approximation is good enough. But for right now, that is what this rule kind of tells us. It tells us that if we have less than 5% of the population, we can treat those events as being independent, which means we can do things like raising to the third power instead of multiplying these three numbers together that are really close but slightly different. And with three numbers, you might say, that wasn't so bad. But what if we have a sample of 1,000,000 and we are going to choose 100 of them out of there? These would be 100 values that are only slightly different right here. So you'd have 100 values only slightly different, or you would have one value raised to the 100th power. The one value to the 100th power would be a much simpler calculation. All right, in the next video, we'll talk more about conditional probabilities, those given probabilities. We will see you there.